In this video, we'll go through the solutions for questions 9 and 10 from last year's Quiz 1. This is a multi-market price discrimination problem, so the topics we covered in Class 3 will be relevant for solving this question. The company German Telesurgery offers a remote surgical assistance service. It employs a team of doctors and specialists that can remotely assist surgeons and address any issues that may arise during the procedures. The team can work up to 500 hours per year, but no more. So that's their capacity constraint, 500 hours. Further, because they are on salary, they are each paid a fixed amount regardless of how many hours they work. In other words, GT has zero marginal cost for each hour of service it's sold up to its capacity of 500 hours per year. Okay. Currently, GT is selling its service to hospitals in Germany and Japan, two different markets. The estimated inverse demand equations by hospitals in the two countries are PG equals 600 minus 3/5 QG, and PJ equals 400 minus 2/5 times QJ. Prices are in euros and quantities are in hours of service per year. Now question 9 says, how many hours per year and at what prices should GT sell to German and Japanese hospitals in order to maximize profits? What is GT's resulting total revenue per year? So we have everything we need to set up this question. We have the two inverse demand curves, okay, and we have their capacity constraint of 500 per year. We're going to find the quantities and prices that maximize profits for the company. So to solve this, let's start out and rewrite our demand curves. So we have PG equals 600 minus 3/5 times QG. And we have PJ equals 400 minus 2/5 QJ. Now, in order to determine first off what quantity they should provide to each country, we're going to solve for marginal revenue equals to 0 for each country independently, see if that satisfies their capacity constraint. If it does, if it's less than the capacity constraint, that's the best the company can do. So let's see if that works. So marginal revenue in the German market, we'll go same intercept and double the slope. So 3/5 will be 6/5 QG. Okay. And revenue will be maximized, which is the same as maximizing profits because there's no marginal cost in this question, be maximized when this is equal to 0. Okay, so this will be the max marginal revenue. Okay. Or this will be the max revenue, I should say. So let's find the QG that makes it happen. So let's bring 6/5 QG to one side equals 600 on the other. QG then is going to be equal to 600 divided by 6 times 5 equal to 500. Okay. So already we can see they're not going to satisfy the capacity constraint unless for some reason they don't want to sell any of their service to Japan, right? Because 500 is the capacity constraint. But let's go ahead and find out what that quantity is in Japan. So here the marginal revenue for Japan, that will be same intercept of 400, double the slope, so 2/5 becomes 4/5, QJ, set that equal to 0. Then we'll have 4/5 QJ equal to 400. QJ maximizes revenue when it is 400 divided by 4 times 5, also equal to 500. So rev max without capacity constraint, we have QJ plus QG equals 500 plus 500 equals 1,000. Okay. That is above our capacity for the service, so we can't do that. So now we need to find the quantities for each type of service that will maximize profits given that constraint of 500 per year. Okay. Now we have the two equations to do that. First, we need the marginal revenue in each market to be equal to one another. So we'll have marginal revenue G equal marginal revenue J. Okay. And we also need to satisfy the capacity constraint. So QG plus QJ has to equal 500. Right, strictly speaking, it's less than or equal to 500, but we already solved previously that they want to offer 1,000 if they can, so that means they definitely want to do 500. So let's go ahead and solve for those two equations. Marginal revenue will be then 600 minus 6 fifth QG equals 400 minus 4 fifths QJ, and then QG plus QJ equals 500. Now the first thing we'll start with this equation here, and we'll write QG in terms of QJ. So QG equals 500 minus QJ. We did that because we're going to plug it into the other equation and solve for QJ. Let's go ahead and do that. 600 minus 6 fifths, and now we're going to plug in this down here. 500 minus QJ equals 400 minus 4 fifths QJ. All right, let's finish this off here. 600 minus 6 times 100 from 6 fifths times 500 plus 6 fifths QJ. Make sure we keep these minus signs straight. It's easy to screw that up on a quiz and lose some points. Equals 400 minus 4 fifths QJ. These are going to cancel out. We can bring the 4 fifths QJ over on the other side, so now we have 10 fifths QJ equals 400. This means QJ is equal to 400 divided by 2 is 200. Now we're essentially done, because we know that QG plus QJ equals 500 when they're maximizing profits. If QJ is 200, that means QG has to equal 300. So we have our two quantities. Now the prices come from the preamble. We know that PG is equal to 600 minus 3 fifths QG. So if we plug in 300 there, we have 600 minus 3 times 300 over 5. So that's 600 minus 180 is 420. So PG is 420. And PJ will then equal 400 minus 2 over 5 times 200, which is our quantity for QJ. That equals 320. So total profits and revenue are the same thing here. Profits are going to be PG times QG plus PJ times QJ. That will give us, from our equations here, what do we have? 420 times 300 plus 320 times 200, and that equals, if we pull out our calculators, that equals 190,000. So that's the best they can do. That's question 9. Let's go back and look at what question 10 asks us. Question 10, the same setup, right, but now something's changed. There's some upgrade, expands capacity from 500 to 2,000 hours per year. Okay. To do that costs 100,000 euros. If GT goes ahead with the upgrade, will they make back their investment over the 5-year time horizon? Let's go back and figure out if they will. To solve this, we're pretty much done from what we did in the previous question. We know that in the best case scenario, with no capacity constraints, GT would offer 1,000 hours per year, 500 in each market. That's below the 2,000 hours per year capacity constraint. So we know they're going to do 500 hours in each year. Let's figure out the prices. Then we'll get the revenue and profits from that. We'll compare it to $100,000 to see if they're better off going forward with the upgrade. Again, remember, previously we found that marginal revenue G equals 0 when QG equals 500, Same thing for Japan. Those are our optimal quantities. Let's now plug those into the inverse demand equations to get our prices. PG equals 600 minus 3 fifths times 500. That's going to be equal to 300. PJ is equal to 400 minus 2 fifths times 500. That's equal to 200. Okay. Now we have our prices, so our revenue from this will be PG times QG plus PJ times QJ. This is again per year profits. So we have 300 times 500 plus 200 times 500, and that is equal to $250,000 per year. So now I have to see, will they make that investment back? The base case is they get $190,000 we solved for in problem 1. So 5 years times $250,000 from the upgrade minus $190,000 that they could earn if they didn't upgrade. Think of this as their opportunity cost. That's $60,000 per year. So 5 times 60,000 equals 300,000 in extra profits from the upgrade. That's greater than the $100,000 investment. Right? They should go forward. That's all there is to these two problems. We've now finished quiz 1. Thank you for your time.